Welcome back. This lesson we're going to look at metamorphic rocks. Metamorphic means to go beyond the form of something, so change its shape. And a metamorphic rock is simply any rock. It can be any rock at all that under the right conditions has changed the structure. So you put it under high heat without melting it, like right up to melting but not quite melting, you can change the shape. So imagine a candy bar in your car that gets all kind of not completely melted but so soft that it could change its shape very easily. That's what's happening. Or pressure. You take something and you squish it and squish it and squish it, you can change the shape of it. So let's see how this applies to rocks. Metamorphosis means to go beyond the form of something. So it's a change of form. And a change of form, if you're talking about a rock, how do you change the form of a rock? Well, it would be like changing the form of a piece of fudge. The only real way you could do it is you could squish it or you could heat it. If you heat it and it becomes droopy, then that's changing the form of that piece of fudge. If you squish it, you've changed the form of the piece of fudge. And essentially, that's exactly what you're doing with rocks. Rocks can be squished. Now you'd think, how could they be squished? They're so solid and they're so heavy. But if you give enough pressure, you can squish a rock, which means that if the grains have anywhere to go at all, they will. All right, so if the crystals are kind of far apart from each other and you add pressure onto that rock, you can squish those crystals together. And if the crystals are all at different angles, imagine dropping a bunch of pencils and the pencils are all at different angles. And now you grab a handful of those pencils, which are meaning you're pushing them together, they'll all realign themselves, okay? Because they're trying to get away from the stress that you're putting on them by grabbing them. So if you have rocks laying way under the ground and the weight of the ground above it, or a mountain or whatever that's above it, is pressing down, you can change the form of the rock. Now, whatever rock that was, now you have a metamorphic rock. So let's say you have an igneous rock. That igneous rock can change the crystals due to pressure and temperature and make it into a metamorphic rock. If you had a sedimentary rock and pressure and temperature are applied, you can change that sedimentary rock into a metamorphic rock. If you already have a metamorphic rock, you can re-change the form of it by applying the correct amount of pressure and temperature. So really, pressure and temperature is the key, okay? So recognizing it is that it is still a solid, it doesn't melt. If it melts, then it's igneous, it's magma again. But as long as it doesn't melt, you can come really close to melting without melting, okay? And you can do that by increasing the pressure or the temperature or both. And you can, and the heat can either come from the molecules being pressed together, that can create a little bit of heat, or heat from deep underneath the ground. So let's say there's radioactive materials that are letting off energy, or you have a magma chamber of a volcano. That amount of heat can do something, okay? If the amount of heat from, say, a magma chamber of a volcano, if you have rocks near that magma chamber but not melted in it, then the heat from that heat source could meltish those rocks. They could make them squishy. And then the pressure that they're under could then undergo some change. Okay. If you remember from the Bowen's reaction, some minerals will crystallize at high temperatures, and others will crystallize for low temperatures. Okay, and what's happening that while it's still a solid, some things become slightly melty. So it would be like if you've ever melted chocolate and you know that some chocolate will melt before the rest of the chocolate does. And if you don't want to scorch it, you would put a little bit of chocolate into some melted chocolate in order to melt it further. So there's minerals will act exactly the same. In fact, chocolate is made up of crystals, just like rocks are. Now, the two main textures of metamorphic rocks are foliated, which means stripes, or non-foliated, which is not stripes. So if the crystals in that rock are long, okay, so like pencils, and you squish them, imagine squishing a bunch of randomly dropped pencils, they're going to realign themselves because you're putting stress on them by trying to pick them up. So minerals that have these types of crystals in them will try to get out of the way as it's being squished, and you end up with foliated rocks. So foliated rocks mostly are due to pressure. If you can imagine grabbing a bunch of pencils, that's pressure. Non-foliated rocks a lot of times has to do with something that is really close to, say, a magma chamber of a volcano. So it's melty. It's not melted, so it hasn't melted yet, but yet it's heated enough to make it really pliable. Okay, imagine heating chocolate or something that's going to make it soft but not melted into liquid. It's the same thing. Non-foliated rocks are often related to some kind of a heat source around. Okay, now grades of metamorphism. Remember, there's two things going on at the same time: pressure differences and temperature differences. Okay, so a lot of times you're going to end up with kind of a diagonal going on. So shale, as you increase the temperature and pressure, will turn into slate. Remember, shale is just mudstone. It can turn into slate. If you then metamorphose that slate, those layers are going to try to get out of the way, and you're going to have those foliated schist. And then you can metamorphose that and turn it into a wavy kind of pattern, and that's called gneiss. So you end up with pressure kind of at different points, not equal pressure, but pressure acting on points, and then you can even get migmatite, which is even further. So it's the same material, but how hot did you make it, or how much pressure did you put it under, can determine based upon that. So these are grades of metamorphism. Now, we've mentioned this before, but maybe you haven't organized it in your mind. Contact metamorphism is when something is close to a magma chamber. And remember, that is not going to be striped. That's going to be non-foliated, so it's going to be like marble, for instance, where your limestone is simply going to reconfigure its bonds into marble, but you're not going to have any stripes or anything in it. Regional is when the whole pressure, like a mountain pressing on it, and that's when you'll end up with these foliated rocks or striped rocks. The last one is hydrothermal, and that just means hot water. So when hot water reacts with a rock, now remember that rock is already in pressure, already under temperature, now add hot water, it would just be like if you had a metal in a forge and you put it in water, or you have a hot glass and then you put it in cold water where it's like a shock. You could change the crystals. You could break a rock, you could crack a rock, you could bend a rock. So hydrothermal metamorphism is if you had water in a chamber that was hot enough that met a rock that was undergoing metamorphism, you could change the crystal of that rock. The economic importance, it really just depends. A lot of times hydrothermal metamorphism can cause veins of minerals to leach out. Say you end up with a vein of gold or a vein of copper, a vein of silver that can then be sold. So that would be very beneficial. Non-metallic would be, there's other stuff that you can sell. Graphite, which is carbon, that's for pencil leads. Talcum powder, all kinds of things like that. So there's various economic importance. And then lastly is the rock cycle. And that's the idea that any type of rock, whether it's igneous, metamorphic, or sedimentary, under the right conditions, can be turned into any other rock. So remember, metamorphosis is heat and pressure. So You take an igneous rock and add heat and pressure, you get a metamorphic rock. You have a sedimentary rock, you add heat and pressure, you can get a metamorphic rock. You could melt any of these rocks and turn it into igneous. Or that once it's a rock, it could break apart by weathering, be transported by erosion, deposited, and then eventually glued into a sedimentary rock. It's not that all these things happen, but they could happen. There's a cycle that could make